record and then start sharing screen. So we will, last class, I think we finished linked list discussion, is it? So you have some idea about linked list, especially the linked way, okay, implementation. So what today we will discuss is about Java. Let me change. It's about a Java collection framework. Java collection, okay, Java collection. And if you recall previously, so I'm going to draw the diagram, the relationship, okay. If you recall that iterable, is it? Iterable is what? Let me ask you a question. Is iterable a class, an abstract class, an interface? Who remembers what is an iterable?
Option C.
Yeah, very good. Okay, so this is our first quiz question. Okay, so our first quiz question, what is iterable? It's a class, an abstract class, or an interface. Okay, so you needed to answer that. So as we just agreed, it's an interface, is it? And extend from it, we can create another interface. So this, because today we discussed Java collection, is it? Another interface is called Java, it's called collection. So this is also an interface, okay. And so far we already discussed various data structures. Data structures, as you may also see this ADT, abstract data type, a lot, okay. So collection in Java interface, it is used to describe the common features among the data structures. So what does that mean? That means you can do some add, do some remove, do get some front item, something like that. Is it empty? So of those. So then you can divide some common interface to support of the purpose. Is it? So that's what we call a collection. Okay, it's an interface. And generally speaking, under Java, under this one, we have three different types of another interface. One is a list. We already see linked list a lot. Is it? Oh, if you are late, you remember we already have our first quiz question completed. First quiz question is regarding that iterable. What is it? It's a class, an abstract class, or an interface, okay. So iterable, we know it's an interface, okay. So please send your answer to the chat. So collection is an interface. Then under it, we have, because we want to subdivide more based on different type of data structure. So first we have list. You can also have set and map, okay. And we are not going to discuss in this class about set and map interface. So we focus on list, okay. So this is also interface. And the list, so we already see array list, linked list, is it? What they did is they can store a collection of items kind of linearly, is it? Linearly, and you can access them sequentially, is it? And also for array list, it's also accessible through index, is it? Index. And the list, one of its features is it support add and remove in the middle, is it? in the middle. It also supports indexing. The indexing. So it's an interface. Is it interface? And under it, if we implement this interface, then, oh, I forgot to mention another one corresponding to the list is the queue. Yeah, previously we also learned the queue interface. Okay, so queue. Oh, why I cannot get? Hold on. Okay, let me get rid of waiting room. Yeah. I need to get back to my annotation is gone. So first let me, oh, then everything is gone. Oh, okay, good. It's still here. Okay, so if you recall previously, we also learned another interface queue that regarding the data structure, stack, queue, DAC, linked list that we learned. So queue at that time when we learned, we also say it's it's an interface, is it? And for queue, its advantage is to do what? Is to access the front and the back, is it? You add and remove at the front and the back, it's pretty quick, is it? So that's the features for queue, is it for queue? And those are the interface, is it interface? And then we learned the linked list. We learn linked list, is it? And when we say learn linked list, when we wanted to create a queue instance, basically we create a linked list instance, is it? But you can see right now, because that linked list implements the queue interface, so it does have the feature of the queue's feature, is it? It's you can add at the back and remove from front, is it? So, but linked list, so linked list, it's also it also implements the list interface. Is it? So linked list, we see you can also add and remove in the middle, is it? And we can also get some specified item indexing, is it? So that's about linked list. And for list, we also learned array list. Is it? Array list, the feature for it is it has some of the feature of array. It's for indexing. Is it? And it also has the features you can also add and remove. Is it? And if you recall, we also learned stack. The stack, is it? And the stack, basically, it's a subclass of another class. We call it a vector. Okay, a vector. So a vector for the stack, it's to access at one end. It's always at the top. Is it at the top? And the vector basically has a lot of similarity to array list. Okay, it's a previous, use it a lot in previous version of the Java, okay, JDK. And but it's not this semester's material, okay, it's regarding synchronization, but vector doesn't support synchronization. Okay, so that's why generally when you want to use something like array, dynamic, growing, and shrinking one, then the best choice for the data structure is array, not vector, okay? Vector, basically the idea is from C++, we also have vector, okay? So anyway, so over here, both array list and vector, okay, they implements only the list interface, okay? Be careful, this two, okay? But linked list, it implements list. It also implements queue interface. Okay, so it's kind of has the characteristic of both. Okay, of both. And for queue, it also has and we discussed the concept about the DAC. Is a double-ended queue. Is it a double-ended queue? And there is another thing later on we will learn in this chapter is about priority queue. Okay, so both of these two, it's just a queue interface. Okay, queue. So in this diagram, so this part of the above part are the interface. Okay, so the purpose of interface is to group a number of methods together. Okay, and then they provide the common characteristic, common operations. Is it as to for each operation how you let it behave? Then depends on all of this class are the concrete class. Is that you can use them to create instance. Is it? Then you implement in your specific way. Is it? And from here we see iterable is top at the very top of the collection. Is it? And the iterable, if you recall, it has a single method called iterator. Is it iterator? That's also an interface, is it? And regarding this iterable, we can also say the purpose is to allow you to do what? Allow you traversing. So basically provide you some way to traverse, is it? That's why we see, okay, the data structure collection, Java collections. So Java collections to provide some mechanism is it for you to store a number of items, is it? And you can add, you can remove, is it? But based on the needs, then you can pick specific different data structures. Okay, so that's the general architecture regarding Java collection. Okay, and regarding set and map, it's not our class information. And then let's see.
You said question one was queue interface?
The first quiz question, you mean?
Yeah.
Oh, yeah, yeah. The iterable interface. Yeah, it's iterable is an interface. Yeah. And if you recall, we learn array list. And then we also learn linked list. So based on the name, the array list, you can guess it. It's implemented using array, is it? But it can grow. And why? If you recall previously in our discussion of stack and queue implemented using array, then in that case is whenever it's full, then you double size the array, is it? And then you do element by element copy to the new array. But of course, so you can check Java official source array list. Okay, so implemented using array. Is it array? But the problem is each time that when it's full, that you need to abandon the old array. That abandon old array, basically leave it as garbage. Okay, so it may involve a lot of garbage collection operation, etc. But because it's implemented using array, so whenever you want to retrieve any element, this is very efficient. Efficient at retrieving element. Is it because it's using index, which is the fastest way. Fastest way. Is it later on when we learn algorithm efficiency, we will say, okay, it's order of the constant. Is it just one? Is it because using indexing? Is it? But if you wanted to do not efficient, for what? For adding or removing in the middle, is it? Or we see anywhere. Is it because what? Because of the shifting, heavy shifting. And of course, nowadays the computers are pretty fast. Is it? The shifting is not a huge issue. Is that a huge issue? But with array lists, there are still the issue of the garbage, because each time when the array is full, then you need to create a new array. Is that? Then you leave the old array dangling there. Is that? So that's not efficient. Okay, linked list we discussed. Is it? We also saw our implementation. Is it? So it's linked implementation. And regarding linked implementation, then we don't have that issue of a lot of, so avoid the issue of a lot of garbage collection operations. Is it? We can avoid that. And abandoned objects. Is it? You avoid that issue. Is it? So linked list, its advantage is it's very efficient at what? At add or remove anywhere. Is it? Because no shifting also. No shifting, is it? And also whenever you want to, it's just linked them together, is it? And it's very efficient in memory management, is it? And the other aspect regarding memory, it's not just the garbage collection operation, okay? I forgot to mention that. Let's see. The other cases is for array in heap, the memory allocation needed to be in contiguous memory block. Is it? So whenever you want like, okay, 100 cell of memory, you got to have that big of free memory block available. Is it? Versus here, linked way. The linked implementation, it doesn't need that. So you have a node here, and you have another node maybe there. So wherever the patch of the memory available, then you can connect them. Is it? It doesn't need to be a big continuous free available one. Is it? So that's also the advantage of linked implementation. Okay, okay, so that's the major difference between these two. Okay, array list and the linked list. Okay, linked list. So this chapter is about collection. Okay, collection. So next, let's take a look an example to better understand it. Let's see, where is my example here? Okay, so here, this is our first example. And in our chapter, you can find the example. It's called test array list and linked list. Okay, and we have two files: a book class file and this text, this testing one. Okay, and here for Java collection, you need to import the utility. Okay, package. And over here, let's see. First, we create an array list. But if you take a close look, for this array list, it's an integer 1, is it? And the type, you said it's list. Why this is allowed? If you recall that diagram, is it? That's because array list implement, this is an interface. It implements the list. This is the linked list. That's why you can use list to declare the variable type. That's allowed. So dynamic binding, it's going to bind to an array list object. Then we call add. Okay, and this add is add at back. Okay, when you just do add. Okay, so we add a number of we add 1, 2, 3, 4. We add 5 numbers. Then later on, we add this 2. Okay, so this is the index. So where you're going to add, it says, oh, I want to add 10 at this index. And I want to add 30 at this index. So for array list, you can also specify where you want to add, not just always add at the back, okay? And then you can just output this array list. Okay, so first let's take a look what it looks like. Can you see the output window?
Yes.
Okay, so the first one, if you see, did you see 10 is at the very beginning? Is it at the sub-0 index? 30 is at the sub-3 index, is it? So that is correct, okay? And then next, let's take a look, the code. Why it's not going back here. And then the next one, what we did here is we create a linked list. This linked list, we just use linked list. That's also fine. But the type is what? It's object. It's very broad, is it? And you see, with this linked list, you call the constructor, you plug in with the array list. So basically here is you create a linked list with an existing array list. That's also fine. Okay, you're allowed to use another collection to create a new data structure. Okay, that's fine. And then for this linked list, you see linked list has the same add method. You can also add at a specified location. So then here, the previous one is all integer, but here you see you add a string. That's also fine because why? Because this linked is an object, is it? And then you can also call remove the last one, and you can also call add first. So you see linked list has it just shows the different operations under it. Okay, and then let's see the output again for this part. And if we take a look for this one, is it you did add green to the first and the red, is it? So you did add those back to the linked list. Okay, so this is regarding linked list. And then next, let's see. So if you recall the iterator, is it the iterable interface gave you that iterator, is it method, and it returns an iterator. The iterator only has the next and the next, is it? So it can only move forward, is it? Move forward, okay. Let's see, okay. So anyway, let's first take a look. So in linked list, okay, in linked list, there is a function, a method called list iterator. So this is an instance method. Instance method of linked list. Okay, linked list. So what it returns? It returns it's called a list iterator. Okay, list iterator. And for the list iterator, okay, so we get this list iterator. And what next it shows is, okay, you see if it's already reached the end, is it? If it is not the end, you get the item. And if it has one, that number one, then you're going to remove it. Okay, and yesterday we also discussed with iterator kind of operation, this is allowed. Within the loop, you can call remove. You can also call add. Okay, so it won't disrupt the iteration itself. Okay, versus the for loop. So over here, if you see, if I use the for each loop, and then I say, oh, if I want to find red and I want to remove, if you run this code, it will throw some exception, okay, called concurrent modification exception. So you cannot achieve this goal, okay? So if you do want to add and remove, when you loop through a linked list or array list, you got to use the iterator, okay? So that's the idea try to show here. Okay, but it's not just stop here. For the iterator, is it that we discussed before, is it only supports forward moving. Is it for, but that list iterator, this iterator in that method list iterator method from a linked list, is it also support backward moving. Okay, backward moving. So you can move from the last to the first. So how do you do that? You call that list iterator method, but you specify where you want to put. So here is where it starts. And here says, okay, at the back. Is it the size of the linked list? At the back. Then it has a method called has previous and previous. So versus has next and next, it has previous and next. So you can backward moving, okay? So that's the idea about this specific list iterator, okay? So in linked list, if you want to move from back to front, then you can use list iterator. Okay, then next, let's see. We create another array list. The type is book. Okay, then we add all of these new books. Is it of the new book? And then we want to see this book array list. Is it? Okay, so let's let's see the running result, what it looks like. Is it here? It also show you can display the linked list forward and backward. Is it backward? And for that unsorted book, is it? That's of the book we added. Is it? So it's unsorted. So it's just add the book. Okay, then let's get back. So anyway, we added the book, and let's take a quick look of the book class. So book class implement clonable and comparable. So it just has two instance variable, ID and name, etc. And we have construct, we have get, and we have set, and the clone. Okay, and this is deep clone because the instance variable either primitive or immutable, etc. So that's a deep copy and the toString. And here is the compare to method for comparable interface, etc. So it uses ID, is it? For comparison. Okay, when ID is the same, then it use name. But if you have more, what are you going to do, etc.? So you can specify. But anyway, this compare to method, this comparable method, we will also see today. So if a class implements iterable interface, or not iterable, comparable interface, okay, then we said that class support, we call it nature ordering. Okay, nature ordering. But nature ordering, be careful. The strategy for comparison is whatever defined by the compare to method. Is it? So here, the compare to method is, okay, first, based on ID comparison. Is it? So if ID the same, then use name for comparison, who is ahead of the other. Is it? That's what this, anyway, this book is comparable, the compare to method. So the sorting, whenever you want to do sorting, is it? So if you recall, we call that a sort method. Is it by default? Then it's going to first sort by ID, then by name. Is it? That's what this defined way to do sorting. If we use this nature ordering, okay, nature ordering. But just think in your application, a lot of time you may see, no, I don't want to do that. I want to do name ordering first. Is it? Then this won't work. Is it? This won't work. So later on, we will see how do we solve this issue. And let's get back here. Okay, so anyway, so over here it's unsorted, is it? But then we can call sort method. Okay, so over here, did you see? This is called collections. Previously, we said Java collection framework, is it? Here, this is called collections. So collections is a Java class. Okay, and this class has a number of static methods. Okay, like sorting, you can do sorting, you can do searching. Okay, so, and you may also do maximizing and minimizing and some other. So the idea is a lot of time for like array list, for linked list, for stack, for queue, etc., for vector, for DAC, for priority, all of this. You may want to sort, you may want to sort. And You don't need to write this kind of searching for each of the method, each of the data structure. Is it? If we can provide, because they all share some common characteristics, is it? So if we can provide methods doing support all of them to doing this, that will be fine. Is it? This achievable? Is it? Why we say this is achievable? Because if you recall over here, we said we discuss collection framework. Is it? And we have this collection interface. Is it? And all this array list, linked list, stack, the DAC is a priority queue. Okay, later on we learn. They implement this collection interface. Is it? Because they implement the collection interface, of course, you can provide some common method to achieve this kind of goal. Is it? Like this sort method. The sort method basically, what's the parameter type? It's just some collection type. So if any class, any object implement this collection interface, then you can use this method. Okay, and this sort method is a static method in collections class. That's what the purpose of this collections class does. Okay, so it group a number of operations together. So all of those operations apply to the mentioned data structures. Okay, so anyway, so here, what I want to do, I want to sort. But whenever, like previously I said, whenever you want to sort, you need to have a policy for sorting. Is it? You want to sort by ID, you want to sort by name, or you want to sort by the number of items, etc. Is it? So over here, definitely for that array of books, array list of books, then it's sorted by ID first, and then by name. Is it? So that's what that is. And we can take a look at the result. Sorted, is it with comparable implemented? If you take a look and compare with the unsorted, so here it's unsorted. This is sorted with nature ordering. Whenever we say nature ordering means it's using the comparable interface, is it? Yeah, it does sort by ID first. If ID the same, it's sorted by name. Is it? It's sort by name. So it does achieve that goal, okay? And then next, let's see. We know this. Then let's see over here, if you take a look. So here I call sort again. This time I have two parameters. The first parameter is that array list. But what is this? Okay, what is this? So let's take a look. Okay, and get back to the book.java, I believe. How do I get? Okay, so we get to the book by Java, the book.java file. And in that file, if you see over here, I define a class called sort by row class. And this class implements, here we have another interface called comparator interface. Okay, comparator interface. And the comparator interface is what? Is a functional interface. Okay, here is our second quiz question. What is a functional interface? Who still remembers? What's its special characteristic? What's the difference between a functional interface and a general interface? Who remembers?
One abstract method.
Very good, very good. Okay, yeah, you can send the answer to the chat. So functional interface, a special interface, only has one abstract method. Be careful, okay, one abstract method. Okay, so that single abstract method is called what? Called compare. It returns some integer, but this time it has two parameters. Okay, based on what type you want to compare. Is it's a book? So here you compare two book. Okay, you compare two book. And then you can specify, over here I said, okay, for this book comparison, I just want to use ID for comparison. Then you can just use ID. Is it? So this kind of comparison, we call it total ordering. That's the benefit for the comparator interface. Okay, it's not to support nature ordering. It supports total ordering. Okay, total ordering, what does that mean? It means it allows different policy for comparison. Okay, different policy for comparison. Okay, so that's comparator. Okay, here it does. And then if over here say we also define sort by name, so it implements comparator. So this time we use name for comparison. Is it? And let's see the next one. The next one, we also implement comparator. This is we customize design and override this compare method, is it? And here we define two. One is compare by name, one is compare by ID, is it? And then you can just call compare to the corresponding compare to, is it? That's because string implements comparable interface, is it? Integer also implement comparable interface. That's why over here you can call the compare to, okay? And if name the same, then I'm going to use ID for comparison. That's what this comparator object works, okay? Okay, we get the idea about then let's go back here, okay? Now we understand, okay, the second parameter is what? Is some object support a comparator interface. Is it? So basically is what? Is you use, over here I say I want to use total ordering instead of the nature ordering. Is it? So this is means I only going to use ID. Is it? Use ID to do sort. Okay. So the collections sort, you have this single parameter. You can also plug in with two parameter sort. Okay. This is called what? Method overloading. And then you can loop. Is it? And next I sort what? I use name to sort. Is it? And then let's continue. And what next? What do you sort? You sort, use the other sort. Is it? You sort by the customer, and then I can also output. Is it output? Okay, so that's regarding sorting. And we can take a quick look. So the sort here, did you see sort by ID? Then it's just by ID. Sort by name, then give you complete different result, is it? And sort customized, then did you see it's first based on name, then by ID, is it? Okay, so it does work, is it? Later on, we will see much more discussion about comparator, okay? But today you just remember compare is called total ordering, okay? Okay, what next we are going to see here, we create a second array list regarding book, is it? And we just add some book. And for array list, it also has this operation, okay, called add all. Okay, and with add all, you can plug in another array list in this case. Is it? Then it will add the second list to the end of the first array list. Basically, you can combine two array lists. And also be careful, okay, for collection, their clone method, or just a shallow copy. Shallow copy. Okay, so if you do want to have deep copy, you can call this add all method. So you create an empty one, then you call add all. Then you create a deep copy, okay, of the other, of the specified array list or linked list or stack, okay? So be careful. In collection, the dot clone automatically gives you as a shallow copy one. Okay, if you do want to have a deeper copy, then you need to use the add all. Okay, and another method called retain all. Okay, retain all. So you can, so this from two different array lists, is it? You said, okay, you want to retain certain items from the other array list, then you can call this retain all method. Okay, retain all method. Okay, and next, let's see another new things here is about Java's. This is also very nice, okay, and it's called pipeline operations. Okay, pipeline operations, and generates with all sorts of aggregation operation. And it's always some collection dot string. Okay, so it uses string. And using string, okay. And you call it a dot string, then it will later on, then you can do some filtering work here. Okay, so what this over here it means is, okay, you want to find in this book array list, book has name symbol. You want to get out of all of the books that has a symbol. Of course, you can write the regular for loop to do it. In that case, then you need to add that filter out. Create another array list, is it? But you see, this pipeline operation is very concise coding, is it? You just have this single statement, but to see you did a lot of work. You did a loop, and then you also did a filtering, is it? Or we say querying. Query, is it? And then something more, is it? And in this case, after you do filtering, what you did? We did another loop, is it? We call for each loop. And for each, then you get all of their names, is it? And what we plugged in here is what? Is a lambda expression. Is it? So this is what Java tried to learn the advantage from some other programming language. Okay, so you pipeline processing. Okay, very concise. And in Python, we see this a lot. Okay, very concise way. And recent number of years, it's move interval more and more like this, okay? Okay, so anyway, let's see the results, okay? What does that mean? The combined two, that I combine two relay. And did you see with that operation, it did pick out all of the books that has CMO in it. That, so, and the output also print out for you. That, so that you don't need to write a very long loop. That multiple line of code. This is just a single line of code. It's a single line of code. And then you complete everything, okay? Okay, so I